Hello, this is Tom Bird. I'm the Fire Weather Program Manager and the Incident Meteorologist at the National Weather Service office in El Paso. And today we'll be doing a seasonal outlook for the 2019 wildfire season. Sorry I can't be with you. I'll be away from the office on your meeting day. So we're going to do this by recording, and just so you know who you're talking to and with, it's me. I'm Tom Bird with the National Weather Service, and we'll get back into the outlook right now, and we're going to do three things. We'll look backwards at what last year looked like, and then we'll follow that by comparing last winter to this current winter that we just got out of, and then we'll take a look ahead at the season itself. The way that we'll look back is we'll do state rankings. Each state in America has about 124 years of climate record, and what we do is for each state is we rank each month or each season relative to just that state's climate record. So these are not numbers that are against state by state, they're each state. So if you look here, this is the first quarter of last year. So this is 2018 we're looking at, January, February, March. So a cool season coming out of winter into spring. And so you take New Mexico, for example, it's 115, and that shows much above normal. And these are the state temperature ranks. So for New Mexico, out of 124 years, this was the 115th warmest period in New Mexico climate history. So it's not ranked against the other states, it's ranked against itself for 124 years. If it would have been the coldest season ever, it would have been a 1. The hottest season ever would have been 124. So 115 is definitely on the much above average, and you saw that also for Arizona. On the right-hand side, we're looking at precipitation ranks for each state. And you can see these numbers are really low for both Arizona and especially for New Mexico. About 62 would be right in the middle. So these are well below that. So these are below average for the beginning of last year. So we'll move to the next 3 months, April, May, and June. And you'll see for New Mexico, you have that 124 on the left-hand side with the temperature. That was the warmest on record out of 124 years of climate record for New Mexico. This ranked as the warmest ever. Right behind that was Arizona at 123 for theirs. So they only had 1 year warmer through this period. All the other were cooler. On the right-hand side, again, you see very dry conditions across the Southwest. The Four Corners states all had much below normal to below normal precipitation, with their rankings being well below 60, which would be right around that midpoint. Now moving into the what we would typically assume to be the monsoon season. Again, looking on the left-hand side at temperature rankings, you can see that much of the western United States hit record warmth through this period, whereas New Mexico is just behind them at 121 out of 124. On the right-hand side, we're back at the precip, and you'll notice New Mexico was quite dry again. Arizona was very much near average at 81, actually just a bit on the high side of average. Now we'll finish off the year by looking at the last 3 months, and you'll notice that we went pretty much near normal for temperatures for much of the western United States. And on the right-hand side, you can see we actually went above normal for precipitation through this period, with New Mexico and especially Texas being much above normal. And some of that, especially off to the east, was a tropical related rainfall. But for us, we just finally kicked in a late monsoon that helped us get our numbers up. If you look at the full year in review for last year, on the left-hand side, you can see all the western United States, including New Mexico and Arizona, were well above normal for temperatures. On the right-hand side, you can see New Mexico in the precipitation ranks fell a fair amount below average, and so did, well, actually Arizona was closer to average. Another way of looking at this is just New Mexico now, not including the rest of the United States or Arizona. We can look at these numbers month by month by month, and so the coolest months would be down at the bottom of the chart where it's blue and you have the lower numbers, and the warmest months on the climate record would be at the top. So you can see for each month, as you go across from left to right, January, February, March, and so on, you're seeing all of these numbers all the way through September are in the much above average. We even had a record couple of months too. So going through the winter and into spring, through the fire season, our temperatures were well above normal. We didn't actually start getting lower temperatures until we got to the cool season, well past our fire season last year. Now we'll look at the precip, and here with all those numbers being on the bottom of the graph, that's the drier month for the climate record of 124 years. So you can see we did have a wet February at 81, but the January, March, and April were really dry, and so was May. And then June, July, we got near average. And then we had a wet month again in October. But you can see going into the fire season, we went in pretty dry with those first 5 months of the year being well below normal. So let's look at this year, and this is for the December, January, and February period, going back last year to this February. So this basically is this winter, and this is what our temperature rankings were. On the main map below, you see on the left-hand side, New Mexico was a bit above normal on temperatures, and Arizona was right at average. If you look at the inset picture there on the left-hand side, I don't know why it's advancing. You can see that last winter the area was way warmer than it was this current winter. On the right-hand side, if you compare the numbers, the main map in the background, 70 was very near normal for New Mexico. 89 was above normal for Arizona. But you'll notice last winter those numbers were very low, so we were very dry last winter. So this winter was not as warm and was much wetter than we saw last winter. So that's how we go into the fire season this year, with a better winter. So this is a comparison of the percent of normal precipitation last year on the left-hand side to this year on the right-hand side through the winter months, December, January, and February. You see a lot more red on the left, and that's where you see those lower numbers in the percent of normal, anywhere between 25% of normal and less for much of the area, especially December, January of last year. We did get a little bit of moisture in the Rio Grande River Valley and the southwestern portions of New Mexico and southeast Arizona last year, but otherwise we stayed pretty dry. Going back to this map, I don't know why it's going forward on its own, but on the right hand side, not as much red, a little more of the cooler colors, indicating a lot more precipitation through the winter months this year. Now let's switch gears a bit and look at drought through the last 10 years or so across the Southwest, and basically we're looking at New Mexico here, and this is a snapshot each year in May, so right in the beginning of the fire season, and you can see what the drought conditions look like across the state, going all the way back to 2011. And you can see how in 2016 and 2017 there on the bottom we actually mitigated that drought. Then last year with the dry winter and the dry spring, we actually brought that drought back into the state. And some of those fires, some of the biggest fires that we've seen in New Mexico history, occurred during some of these drought conditions. This is going back all the way to 2000, and these colors represent the percentage of the area of the state of New Mexico that was in each one of these drought states. And so you get a good indication of just how expansive the drought was year by year by year as we go through the time. And you can see how last year it peaked again in 2018, but then started waning again as we went into the early part of 2019. So here's a comparison of last year to this year now on our current drought conditions. On the left is last year, 2018 in April. You can see we had expansive extreme drought across the Four Corners, northern New Mexico, a good portion of Arizona, Utah, and Colorado. On the right-hand side, look just how much improved our drought condition is. We still have some of this mustard color, which is severe drought along the Four Corners, but it is very much improved across most of the entire western United States from last year. Now when we look at the drought monitor class change, it shows how many classes we've improved are retrograded or not changed. And so if you look at all this green across the Southwest and the Southern Plains, it's showing 1, 2, 3 class changes in the improved area. So much better conditions this year as far as drought relative to what we saw last year. Okay, now let's shift gears again. And we always talk about El Nino and La Nina. We call it the ENSO pattern. And last year we were in La Nina, and that tends to keep us dry. And if you look on the bottom of this, you'll see that Pacific jet stream coming in with the cloud and the snow on it. Usually what happens during La Nina is the storms track too far north of our area, so we stay dry and warm down in the southern United States. But this year, with the green check, we were El Nino. And El Nino takes that same jet stream and pushes it south and allows those storms to come in further south and keeps us wetter and cooler on average during that winter time. And that's exactly what we experienced. And here's a good example of that. On the left-hand side is the snowtail basins. So this is snow water equivalent for each one of these colored regions. That's a basin, a snow basin. And by color, you can tell whether that basin is above average on snowfall. This was in February of last year. You could see that that blue line is kind of the storm track. You see the clouds along that. We had high pressure settled over the southwest for most of last winter, so that kept the storms north. And north of that storm track, the basins got really good snowfall. You see those greens and blues; those are above average snow amounts in those basins last year. And below that storm track, that's usually the dry side of the storms, and so you can see all those basins were in the red, which is well below normal. So compare that to this year. So that was typical La Nina. So let's compare to this year. With the La Nina now, those storms have been traveling much further south, and so they've been given the snow basins to the south much more snow, and so you see the blue has migrated south this year, meaning that these basins have average to above average precipitation, and even went all the way south into Arizona and a good portion of northern New Mexico this year. So that was the typical El Nino that we saw this winter. So here is a current. We'll look at this later, but that's what it looks like today in New Mexico and Arizona. So here's a comparison last year to this year of the snowpack, and you can see just how low those numbers were on the left-hand side last year, with almost no snow across the state, and that compares to just March the 13th, about 2.5 weeks ago, maybe 3 weeks ago. On the right-hand side, you saw much better numbers as far as snow, but that was about 3 weeks ago. And so here's the current snapshot I'll pull up. We've had a lot of snow melt along the southern portion of the state. If you look at the San Francisco basin, it was at 104 just 15-20 days ago, and here it's all the way down to 5%. So we've had some rapid melt across the southwest within the last couple of weeks. Now, the reason we talk about El Nino and La Nina and use it to try to figure out what the weather's going to do going forward is the atmosphere gets its energy, which creates the weather we experience, from the heat or the lack of heat in the ocean. So we're always looking at the sea surface temperatures across the Atlantic, the Pacific, to try to determine how that impacts our weather. And we make correlations between the ocean temperatures and the weather that we get on average. And so looking here at this on the left, if you look along the equator, and that's that dotted line, and on the left-hand side, you see those blue colors across the ocean. That's a La Nina state where the waters are cooler than normal. On the right-hand side is El Nino. You see those warm colors along the equator. That's when the temperatures are warmer than normal. So here's what we looked at like on the left-hand side last year, on the right-hand side currently. So you saw those blue ocean waters last year, which was a La Nina phase, and on the right-hand side on the top you see now those are warm colors indicating above normal temperatures, which is El Nino phase. So last year we were La Nina, and sure enough we were dry as anticipated, and this year we were El Nino, and we were wetter and cooler than what is typical. This is kind of a running look at the sea surface temperature anomaly. That red line is the average, or the zero line. The dotted black line on the bottom is that. That red line is where if you're warmer than that line, sea surface temperature-wise, you're in the El Nino phase. You can see we've been in El Nino for quite some time. It started waning towards the end of last year, but this year it's been actually strengthening again, but going back towards a stronger El Nino phase going into fire season. The models, if you look at these, the spaghetti plot is what we call this, is a bunch of different models looking at sea surface temperature forecasts going forward in time. And you'll notice through the spring and in the summer, they all keep those temperatures above that neutral line, keeping it warm. So we anticipate that El Nino conditions are currently present, and we can expect them to continue into summer. Another model we look at shows the exact same thing and actually shows El Nino getting stronger, which it is doing. So this is one that's verifying very nicely. So it actually keeps El Nino all the way through into the fall. So what do we care? Well, this is what it usually tends to do to us here in the Southwest. You'll notice these are box and whisker plots. On the left-hand side, we're looking at temperature. On the right-hand side, we're looking at precipitation. On the left-hand side, look at that neutral box, and that's where your temperature should be when those sea surface temperatures are what they should be, average. But if they're warmer than average, that's the left box. That's an El Nino condition. And you'll see it shows that our temperatures are usually cooler than normal. This is for March, April, and May. And looking on the right-hand side, the precipitation, you see that neutral box, but we're warmer than normal, El Nino phase, and that shows that box being higher, which means more precipitation to be expected for March, April, May. When we move into the later, warmer months, June, July, August, you'll notice the difference between El Nino, neutral, and La Nina is not quite as readily noticeable as it was for those earlier 3 months, because as we get warmer, the association between the sea surface temperature and the weather is not quite as clear cut, so there's not as big a difference. So we're still showing slightly cooler than typical conditions, and just very so much slightly wetter than normal conditions possible for June, July, and August. Now let's look at current drought. This is what the drought monitor looks like for April the 2nd. And you'll notice even as far as just 3 weeks ago, we've made improvements on our drought across the region. There is still a little bit of severe drought right there southeast of the Four Corners, but much of the area has mitigated drought if you compare it to February of last year, which just popped up on the right. And here's the seasonal outlook. And if you'll notice across the Southwest, that green is drought removal likely, and that marshmallow color is drought remains but improves. So we don't really see ourselves reversing this trend and going back into drought. So let's look at the outlooks. Now we're looking forward, and this is for the rest of March. We do see a little warm signature across New Mexico for March in the probabilities of whether the temperature would be either normal, warmer than normal, or cooler than normal. Then if you look at the precipitation, as you move north and west across the Southwest, you see better chances of it being wetter than average with equal chances to the southeast. Now going to a 3-month outlook, which includes March, April, and May. Equal chances for temperature, meaning not a strong signal that we'd be either warmer or cooler than normal. On the right-hand side, you see a bunch of green across the region, indicating wetter than typical is the better forecast or the higher probability for these 3-month period. Now looking at a different model, this is the climate forecast system, or the coupled forecast system, and looking at March, April, May, and June. These are all temperatures. The blue colors are cooler than normal forecast. The warm temperatures are warmer than normal temperature forecast, and so you can see March looks a little bit warmer than average over New Mexico, but cooler than average or average in Arizona. You can see as we get into April, May, cooler than normal tends to prevail across the region. Then June, you're starting to see a bunch of average across the region. Now we'll switch gears and go look at the precipitation for these same months from the same forecast model. And you can see that drier in March, and then some better probabilities for wetter than average are average from April through June. Now we get July, August, and September, getting into the latter part of the monsoon, and you can see the temperatures are all favoring above average as far as the probability of what we'll be seeing through this period. Then on precipitation, equal chances. And what that means is you could see either drier, wetter than normal or normal, because there's just not any strong indicators that we would be one way or another. So now let's switch gears one last time and go to the predictive services outlook. And this is what they had created for March about 3 weeks ago. They showed our area, and this also is like a three-stage forecast. You can either be above normal for significant wildfire potential, below normal, or normal, and they're showing all normal for region 3, our area. And you can see in the inset up there on the right, that was last year's forecast for last year, and you're looking at the forecast for this year in the big map. And so we'll move to April. Again, really no indication across all of region 3 that we'd see anything different than normal. Last year we were much above normal or much of the area was above normal on the potential. And we move into May, and we're actually seeing a likelihood, or they are anyway, of below normal significant wildfire potential for much of the region versus last year where the whole region was above normal on potential. We go to June, and the southwestern portion of region 3 in southern Arizona is starting to light up with some above normal potential, whereas the north and northeastern portions are still staying below normal. And then finally for July, we see the area go back to normal potential. So the way they work it up is they look at these 5 factors: drought, fine fuels, seasonal temperature, weather pattern, and monsoon. So the drought, there is still a very small area near the Four Corners that is in severe drought, but we've much improved the rest of the area over what we saw last year. Fine fuels conditions, we've had significant rainfall across the region, which will lend to growing some fine fuels. So we'll be normal to above normal loading with the fuel continuity across the region, especially in southern and southeastern Arizona and in the eastern and southeastern plains. For the seasonal temperature and precipitation, more moist and cooler focus north and west, and drier and mild south and east over the past 3 months is what we've seen. So as we look into the spring and early summer weather pattern, we expect a wide variety in the weather pattern with the current conditions. There's a big potential there for a transition into what we call a dynamic and active mid to late spring, meaning we'll still see some storm systems moving through. But eventually, as we get warmer, we'll shift from a cooler, wetter type pattern to the typical drier, warmer spring that we expect. We'll see some increased moisture and some widely fluctuating temperatures focused east as we get into May and June. That's where we see those lower potentials. And then for the monsoon, that thing is difficult to predict. Every year it is, but overall there are some indications that cause concern that we might see a later than normal onset and a less robust amount of moisture through it, especially as we get west of the divide, with better moisture likely as we go further east across the region. So that pretty much, I believe, finishes what I had for you. If you have any questions, contact our office. My email address is not on here, but it's tom.bird, BIRD, at NOAA.gov. Be happy to answer any questions. Thank you.